warm welcome to all of you. Today we are going to start our discussion on materials requirement planning. In the previous two lectures we have discussed various tools and techniques of inventory management. We have seen that in inventory we have so many types of tools such as ABC analysis we have seen what are the other specific tools like economic order quantity model, production order quantity model, and we have seen basics of materials requirement. And we have seen that these tools can be used by any organization or an enterprise to increase their profitability. Today we are going to discuss regarding the materials requirement planning, which is also a very important aspect and is being used by the modern day industry. Many companies are using the MRP softwares for planning their materials requirement as well as ordering as well as the inventory. So many functions are there for materials requirement planning software, and it works on a certain set of input. There is a input which we give, which we provide to this. Suppose till now we know that MRP is a black box. To that black box we are providing certain input, and that input is converted by the logic which has been inbuilt in that black box into a certain desired output. So in today's lecture we will see that what is the input which has to be given to the MRP and what is the output that we can think of getting from the MRP, or what we are getting as compared to the software that is there available in the market. So if a software is available on MRP, we need to understand that what is the input and what is the output, and a brief understanding of how the software operates. So that we are going to discuss today in this particular lecture. Initially we will have a introduction or a basic definition of a MRP. Then we will see what are the various input parameters. Then we will see how the MRP works, and then we will see what is the output that we get out of materials requirement planning. Basically we have seen in inventory management that we have to take 2 or 3 very important decisions. What are those decisions? The decisions are, what do we need to procure? Like what is the requirement, what is the item, what is the component that we want to procure or that we want to purchase. Second thing is, when do we need to purchase? That we need to understand that this material will be required by the end of December. So we have to take a decision depending upon the lead time that at what particular moment of time we should place an order. So the time component is also very important. First thing is to identify the component that we have to purchase. Then we have to take a decision that when we have to purchase. And then the last most important question is that how much we have to purchase, which means that what quantity we need to purchase. So 3 important questions are that what we have to purchase, then when we have to purchase, and how much we have to purchase. So when we have answer to all these 3 questions, we will be able to save a lot of money for our company if we have a judicious decision for all these elements of inventory management. So MRP software helps us understand and helps us in a way that we can generate a lot of profit for our organization. But certainly there are certain drawbacks of the MRP software also, or the materials requirement planning system also. So what are those drawbacks? That also we will see. Advantage, already one of the most important advantage, that it improves the profitability of the company, I have already told you. But there are certain disadvantages also related to this software. What are the limitation areas? That also we are going to understand in today's lecture. So let's now start the discussion. I have given you a brief summary of what are we going to discuss in today's lecture. I will again like to summarize what we cover in this lecture so that you have a overall idea that what is materials requirement planning. So let's now start the discussion. First part is the introduction. Materials requirement planning is a means for determining the number of parts, components and materials needed to produce a product. So you can say it is a mean by which we can identify that if we know. Let's take an example, because I feel with the help of examples we are able to understand the problem in a much better way and in a much easier way. Now suppose we want to manufacture a car. we can understand that when we have to manufacture a car, when we have to make a car, so many different components, maybe thousands of different components and sub-assemblies need to be assembled to make a complete car. Now let us understand that we have a forecast. Suppose a particular company has a forecast that they would be able to sell 1000 cars per month. Now depending on 1000 number of cars that will be used or that will be produced by that company in that particular month, we need to understand that how many different components which will make up that car would be required. So MRP will help us to generate a demand for all those components which would be required to make one particular car. And now if we have a certain demand of suppose 1000 cars, we will be able to see that what is the requirement of the number of components that will be used to manufacture 1000 cars. So in a way this will be helping us to identify the requirement of those particular parts. So here in the very basic definition we can see materials requirement planning is a means of determining the number of parts. So how determining? It will help us to on the basis of certain logic. For example, for one particular automobile or one particular car, suppose we need 4 tires. So this is a logic that for this particular product the number of sub-components required, maybe tires, is 4. So determining the number of parts, components and materials needed to produce a product. For one product it will generate the demand for different components, and then that can be multiplied to the number of products that are there for one particular season or one particular year or one particular week. So on the basis of that we will be able to very easily manage the materials within our organization. So MRP provides time scheduling information specifying when each of the materials, parts and components should be ordered or produced. So it will even help us to schedule our procurement process, schedule our materials management process, that when an order should be placed if we want a particular component or a part by such and such date. Suppose for procurement of a particular material 10 days are required. So it is required suppose on 25th of December, and 10 days is the procurement time, or we can say the lead time. Then we have to place a order 15 days, 10 days in advance, that is by 15th of December, so that by 15th we place the order and by 25th we will be able to receive the order. So what I mean to say is that in materials requirement planning we are able to determine that how many parts, components would be required to make a final product, and at what time we should start the procurement process, so that any time when the need arises for a particular part or a material, we are ready with that particular material in our inventory. So two things are there. First thing is that how many numbers are required, which you can see determining the number of parts in the first part of your slide, and the second you can see when it is required, means MRP provides time scheduling information specifying when each of the materials, parts and components should be ordered or produced. Sometimes we produce the items within our own organization, then we need to take a decision that when the production for that particular part or component should start. So the two catchwords in this slide is that determining the number of parts and when each of these parts should be ordered or produced. So determining number, that is one thing, and second thing is the what we have seen in the slide, that when it is required. So two important things are there on this slide which forms the basic backbone of materials requirement planning. Now let us see the definition. How do we define materials requirement planning? MRP constitutes a set of techniques that use bill of material, inventory data and the master production schedule to calculate requirements for materials. So this definition is giving us an idea that what are the inputs and what is the specified output of a materials requirement planning system. For your information, you can see on your slide or on your screen that MRP constitutes a set of techniques that uses. Now uses means that these are the input parameters. Now what are the input parameters? The bill of material, inventory data and the master production schedule. So if we have these three things available with us, then we can feel or we can be confident that the MRP will be able to generate the number of components required for finally making the product, and when the procurement should be done or when the production should be started. So in this slide we are seeing that what is the input and how it will be used to generate the output. So by now we have understood that how materials requirement planning works, what are the input parameters, and then subsequently we will see that what are these three things. With the help of certain examples or with the help of certain diagrams, we will be trying to understand that what is basically a bill of materials, what is basically a master production schedule, what is the inventory data that is required, that we will understand in today's lecture. Now, materials requirement planning system based on the master production schedule, a materials requirement planning system. Now what it is going to do, or if we have this master production schedule available with us, it creates schedules identifying the specific parts and materials required to produce end items. Now we can see this already, I have told you, but again discussing regarding the system based on the master production schedule. If we have the master production schedule available with us, on the basis of that schedule, a materials requirement planning system, a MRP system, this will create schedules identifying the specific parts and materials required to produce the item. So we will be able to identify the specific parts and materials which are required to produce that item. I have already given an example of a car. So if the final product is a car, it will be able to generate that what are the various components that are required to finally manufacture the product. It determines the exact unit numbers needed. Now it will also be able to tell us that what is the requirement, what is the amount, what is the number of components or part required. Then it will determine the dates when orders for those materials should be released based on the lead time. Already I have explained this thing, that if suppose we require a particular component on a certain date and we know the lead time for that particular product, or sorry, for that particular component, we should be able to place an order by such and such date depending upon the lead time. So basically master production schedule is an input parameter, and if we have this input, on the basis of this input we will be able to generate these three important information. Now let us see that what is how the MRP system is going to work. These are the all individual components that will be used by the MRP system. So you can see we need to have sales forecast. We will have some lectures on sales forecast also in this series of lectures on industrial engineering. So what is a sales forecast? Why do we need to do sales forecast? What are the most important techniques of generating a sales forecast? That we will be able to understand with the help of a large number of examples. So and we will see what are the different types or different classifications of forecasting techniques. So all that we will cover, but here in a MRP system we need to generate a sales forecast. Why it is required? Because you see, we need to understand that for a particular month or for a particular year or for certain specified amount of time, we should know how many final products we require, because on the basis of that number only MRP system will work to generate that what are the requirements of the parts, components or certain sub-assemblies which are going to make up the final product. This I will explain with the help of a particular diagram. But sales forecast is very important in case of MRP system in order to identify the demand of the final product. Similarly, the customer order, because the customer order is always fixed, this is something that we are definitely going to make. Forecast basically is our guesswork on the basis of certain statistical techniques or certain mathematical models. We will be generating, okay, we may be able to sell this much number of components. That is our forecast, that is our guesswork. And customer order is certain thing that is very specific. For example, a particular company only manufactures the things which has been ordered by the customer, then their forecast is very accurate because they are working on a particular customer order. But if there is no customer order, we are manufacturing the things on our own and then selling it into the market, then we have to do certain forecasting that how many components we would be able to sell in the market. So two types of demands are adding up here that we need to understand. One is a very sure demand, that is placed, a order placed by the customer. Second is a little bit probabilistic type of demand where we are using our intuition, we are using certain tools established in the textbooks to generate the demand. So two types of demands is coming in picture, one by the sales forecast and another by the customer order, and then these two will be used in the master production schedule. Then there is a service parts requirement, there are certain engineering changes in the product. Now we need to understand that a particular product we are manufacturing, it is being made of certain number of parts, certain number of materials, certain number of sub assemblies. Now that particular component, that particular product, if the engineering design changes for that product, instead of using 4 nuts and bolts, now we are using 2 nuts and bolts only, then we need, the total system will have to adapt to that kind of an engineering change, because initially when we know this is the final product, the output will be generated, or within the system a need will arise that 4 nuts and 4 components will be required in order to process this final product. But when the engineering design changes, we know that we need only 2 nuts and 2 bolts, then the system has to be adaptable to that kind of a scenario. So engineering changes is also an input to the MRP system. Similarly, bill of materials will be changed on the basis of the engineering changes. So how these different items are clubbed together in a MRP system, that you can see for yourself now. Sales forecast and customer order, already I have told you, these will be used in the master production schedule. Engineering changes will alter the bill of materials. Similarly, the service parts requirements, that will alter the inventory status file, and these three will then finally add up to the MRP system. So we can see that from all the areas the input is coming, and then this is being used in the MRP system. From where the input is coming? Sales forecast, customer order. Similarly, if there are certain changes, I have explained this with the help of a diagram, with the help of an example of nuts and bolts. So engineering changes, customer order, sales forecast, similarly service parts requirement, they will update the inventory status file, and these three will be used in the MRP system as the MRP inputs. On the basis of these three inputs, the system will itself generate a certain output. So master production schedule. Now we try to understand that what basically master production schedule is. Although till now we have understood that this is one of the primary inputs to the MRP system, but what basically master production schedule is? It is a list of items indicating end products to be produced. So it will tell us that what is the number of end products that we need to produce. In our example, I have already told 1000 number of cars per month, or 1000 number of cars per year, or we can say 50 cars per week. So that basically is a list of items indicating end products to be produced. So that is basically the end product, and how that end product can be made, that end product basically is assembled from a number of small different parts, materials or sub assemblies. So this will help us to identify what is the final product that is required. So it is a list of items indicating end products to be produced. This contains item name and code, maybe certain times we have to enter the code. Quantity to be produced, it will tell us the number that has to be produced. Already I have given you an example, 500 or 1000. And the timings for completing the production. So by week, this will be able to tell us that after the end of suppose 6 weeks, this much number of products should be produced. After the end of 12 weeks, this much production should be done, or this much number of products should be ready. Based on estimates of product demand, that is sales forecast. Already I have told that sales forecast we have discussed in other lectures on sales forecasting, but on the basis of sales forecast, master production schedule will be able to identify what is going to be the product demand. So also it can be on the basis of customer requirement. If customer requirement is there, then we have a sure short MPS system working, that this much number of components are required by such and such date. Otherwise, if we do not have a sure shot demand, that has been placed by the customer, we will use sales forecasting tool to generate the demand. Now on your screen you can see a MPS for products P6 and P8. Suppose P6 and P8 are the codes. This is the weeks. Suppose the month running is September. So first week, second week, third week and fourth week. This is the product. This is product P6 and product P8. Now you can see that by second week product 6 requirement is 70. In first week the product 8 requirement is 40. Similarly by fourth week the product 6 requirement is 100, and by fourth week product 8 requirement is 60, and third week 80. So week wise we know that how many components have to be made for P6 and similarly for P8. Now this is a master production schedule. With respect to time, we know the quantity that has to be produced. Now for this quantity, suppose product 6 requires certain number of materials, certain number of sub assemblies which will be finally assembled together to make product P6. So that will be generated by the MRP system. We know in our MPS that this is the requirement, then the MRP system will work on the basis of this MPS input and it will generate the independent this is the independent demand, then it will generate the dependent demand. So we will see with the help of an example that what is independent and what is dependent demand. But I think by this diagram it is very clear that what is a master production schedule. For a particular month, 4 weeks, every week we know how much is the quantity that has to be produced for the final product. This is for the final product, product P6 and product P8. Now we come on to the another input parameter. Now till now we have understood what is master production schedule. So basically there are 3 input parameters. Second input parameter is the bill of materials file. So first point is it provides a list of materials and their quantities required to produce the end items. So in order to understand it, we can take an example of a particular dish that we are going to prepare. So bill of materials basically provides us the recipe for that particular dish. We know that we are going to produce a particular dish. For example, we say we want to produce a samosa, or we want to make a samosa. For making a samosa, we need to understand what will be the input parameters, or what will be the ingredients, or what will be the recipe of making a samosa. So this bill of materials is going to help us that if the final product is known and the quantity is known, how it is going to be made, and what will be the materials, what will be the components, what will be the particular sub assemblies that will join together to make the final product. So first, on your screen you can see it provides a list of materials and their quantities required to produce the end item. It contains the list of finished products, material needed for each finished product in units. So number is very important here. It will tell that this much number of units for this particular component are required to manufacture the final product. Assembly structure, sub assemblies, parts and material. This already I have explained with the help of an example. If final product is known, then bill of materials will generate the number of sub parts, assemblies required to make the final product. Similarly, bill of materials file is revised every time there is a change in product design or specification. If you remember, in the diagram, very first diagram in which the MRP inputs were shown, that every engineering change was going to the bill of materials file. So whenever the engineering design changes, the bill of materials file is updated. So bill of materials is revised every time there is a change in product design or specification. Any engineering change will lead to the updation of the bill of materials file. Already I have explained with the help of an example where initial design was using 4 nuts and 4 bolts. New design is using 2 nuts and 2 bolts. So that information has to be updated in the bill of materials file. Now here, suppose with the help of an example, we can see on your screen, you can say that the product, you can see that the product A has to be manufactured. Now there are 3 sub assemblies which will be finally assembled to produce product A. So this is basically the requirement for finally producing the product A. Now product A requires sub assembly 1, sub-assembly 2 and sub-assembly 3. Now further sub-assembly 1 will be made up by joining two parts together, that is X and Y. Now X and Y will be assembled together to form sub-assembly 1, and similarly sub-assembly 2 would be requiring X and Z, and sub-assembly 3 will be requiring Y and Z. So we should know that how many X, Y and Z are required in order to finally produce product A, and similarly one part Y will directly go into the product A. So product A requires four important ingredients to be finally manufactured. Now what are those four important ingredients that you can see on your screen, and we need to understand how many product A will be made. That we will be knowing from the master production schedule, that by such and such week we require this quantity of product A or this much quantity of product A, and when that is known, on the basis of that we will be able to generate how many sub assembly 1 will be required, how many sub assembly 2 will be required, how many sub assembly 3 will be required. On the basis of sub assemblies we will be able to identify how much quantity of X, how much quantity of Y and how much quantity of Z will be required. So this is basically the importance of materials requirement planning, that this will be able to identify the quantity what is required to finally make the product A. Now third important part is the inventory status file. Now three important ingredients or three important inputs are there to the MRP system. Two already we have understood. What are those two? The master production schedule and the bill of materials. Now the third part is the inventory status file. It provides a computerized record of each material physically held in the system. Now all these materials, if we go to the previous slide, you can see that product A requires sub assembly 1, 2, 3. Now sub assembly 1, 2, 3 requires components X, Y and Z. So how many components X are present, how many Y and how many Z are present in the inventory, that will be stored in a computerized manner in the particular machine or in a particular computer, and that will be storing all the information, how much quantity is there, how many has been ordered, how much has been sent to the shop floor for the assembly. All that record would be maintained in a computer. There will only be one inventory status for individual material, even if it is used at different levels of production or in different end products. So there would be one inventory status. That is very clear. Once again I will go through this point. There will only be one inventory status for individual material. Now suppose individual material is X, so there will be one inventory status for that, even if it is used at different levels of production or in different end products. Now in the previous slide we have seen product A only. Suppose the company is manufacturing different products like product B, product C, product D. Now for different products same material can be used, but the inventory status will be singular only or same only, or individual material will have only one inventory status, that is clearly mentioned in the second point on your screen. Now what does the inventory status file indicate? Now inventory status file will indicate the material code. There can be certain coding mechanism or certain coding schemes used for the material, so it will indicate the material code, it will indicate the material name. Inventory on hand, it means how many numbers are physically available in the inventory. So inventory on hand will also be indicated in the inventory status file. Then inventory on order, ordered but yet to arrive. So we have already seen in our previous lectures on inventory management that there is a lead time between placing an order and receiving an order. So during that period it will indicate what is inventory on order. Means that order has already been placed but we have not yet received the lot of inventory, or we have not yet received the quantity that we have already ordered. So in a particular system, if we take an example, in a particular software, the number or this much quantity can be shown by a different color. Suppose we are showing that on hand inventory or physically available inventory by a blue color, that this is already available with us, we can use yellow color to show that inventory on order, so that we can very easily be able to distinguish that this is what we are going to receive after so many number of days. So that will also be an data that will be available in the inventory status file. Similarly, customer order for item, that will also be available in the inventory status file. The inventory status file also contains the following information. It contains information such as the lot size, the lead times, the safety stock level, as well as the scrap rate. Now, safety stock level and scrap rate are two new terms that are coming in our discussion. Now, safety stock level basically is a stock or a buffer that we are maintaining if we have an independent demand. So if the demand is changing or irregular demand is there, sometimes we don't know that how much number of parts or components would be required. In that particular scenario, that particular case, we need to keep certain things in stock or certain things as a buffer stock. Although we have a certain amount of inventory, we know that for one particular week, suppose 1000 components would be required, but sometimes the requirements, because of the change in the demand, there may be requirement of 1200 components. So 1000 we have already kept, but there is a requirement of 1200, so 200 extra we need. So that basically we are maintaining as a safety stock. So that will not be used in normal course of time, but it may be required if the need arises. So that basically is the safety stock level. And similarly, the scrap rate, sometime within the inventory, when we manage so many different things, there is a damage to one or the other component stored in the inventory. So that becomes therefore the scrap, and the scrap rate is also stored in the inventory status file. Lead time and lot size already we have discussed, but I feel that a little more discussion on the lead time will help us to understand the manufacturing or the normal lead time and the manufacturing lead time in a more better manner and in a more concise manner, and how lead time is used by the companies, that we will be able to understand. So let's now have a very brief introduction to the lead time. It is the time needed for completing the job from the initial stage to the final stage. Now, suppose we are ordering today, we are receiving after 10 days, so the lead time becomes 10. So it is basically of two types. First is the ordering lead time, start of purchasing process to the receipt from the supplier. So today we start the process, suppose after 10 days we receive the order, we will say that the lead time is 10 days. Similarly, there is a manufacturing lead time also, that is the processing of part through the machines specified on the route sheet. So processing of part through the machines specified on the route sheet. For a particular route sheet, we know that this much time would be required to finally process this material. So that basically is called the manufacturing lead time. So we have a ordering lead time, we have a manufacturing lead time. So how lead time is used, that you can see on your screen. How MRP uses lead time data. Now lead time, we know that if today we order, we will receive it after 7 days. So that is used by the MRP system. Now on your screen there is a very simple diagram. Suppose this is the number of days. We want a final product by this day, maybe by the end of 7th day. Last sub-assembly 1 will be needed on 6th day. Place order for sub-assembly 1 because the lead time may be 2 days. 2 days would be required for order sub-assembly 1 to be procured. Start of production is 2 days. If we know that sub-assembly 1 would require 2 days to process, then we can say at start sub-assembly 1 should, the production of sub-assembly 1 should start at this second day. And suppose 1 day is required for the raw material, then the order the raw material here. So we have a offset. We know that the final product is required after 7 days. How should we plan so that we are able to produce that final product? So we need sub-assembly 1. For sub-assembly 1 we need some raw material. So this will, the lead time will be used in this way for a particular company. Now this is the offset in this direction. So we know that 7th day this is required. How should we plan in advance so that by the end of 7th day we are able to produce the final product? Now, why this lead time is important? Because the characteristics of demand always changes. Now, there is a dependent demand and there is a lumpy demand. Now, dependent demand basically is if we know that this much number of components have to be produced, suppose 500. Now, these 500 components require, suppose, any part A which is required in 4 numbers. Now, we know 500 final products have to be produced. Each product will require 4 components A, then 500 multiplied by 4 will give us the dependent demand. So, I have given you an example. Now, let us see how we can define the dependent demand. Product demand related to other items, as item is component of other product. So, final product we know and this item is a component of that particular product. Now, lumpy demand basically is demand is sudden or is in large quantity increment so as to take a batch or a final product. Sometimes the lumpy demand is there, maybe sudden change in the demand. So, dependent demand may be very stable, lumpy will be very exaggerated or maybe very high or very low at times. Now, let us see what is an independent and a dependent demand. On your screen you can say, just to recall, now we want to manufacture product A. Now, A requires part B and part C. Final product is A. Part B and C will be joined together to make A. And how we will be able to make B? B will require D and E. So, D and E will be assembled to make B and then B and C will be assembled to finally make A. In bracket is the requirement shown for part B. So, 4 parts B will be joined with 2 parts of C to make A. Similarly, how B will be made? 2 parts of D and 1 part of E would be joined together to make B. Similarly, 3 parts of D and 2 parts of F will be joined together to make C. And finally, B and C will be joined together to make A. Now, this is the independent demand. I have already told the final product is the independent demand and that is basically the end item on your screen. And this is the dependent demand, that is the component parts. Now, component parts will add up to make the end item or the final product. So, this is the dependent demand. Once we know what is going to be A, the number of A. Number of A, I mean to say that whether we are requiring 500 product A or 1000 quantity or 5000 quantity of product A. On the basis of that independent demand, we will be very easily able to understand how many components B would be required, how many components C would be required. And once we know how many components B are required, we would be very easily able to understand how many D and E components would be required. So, on the basis of the independent demand, we would be very easily able to generate a dependent demand, which is done by the MRP system. Now, independent demand is uncertain. Always we know that why sales forecasting is done, so that to come close to that particular demand that is independent. We don't know how many components would be sold in the market or how many products would be sold in the market. So, in order to come close to that, we use certain sales forecasting tools to generate that independent demand or the quantity that would be sold in the market. Dependent demand therefore becomes certain. Once we know that this is the independent demand, maybe 100, then we can very easily understand that what is going to be the dependent demand for the components that are going to add up to make the end item or the final product. Now, this is continuous versus lumpy demand. Now, this is a stable demand, more or less it is constant, but lumpy demand you can see sometimes we have very large. This is on x-axis, this is time. At one particular moment of time the demand is high, then there is no demand. After some time again certain demand is there, then there is no demand, then there is a certain demand. So, we can see basically if we have a stable demand, the system would be able to adapt very quickly, but if the lumpy demand is there, then it is very difficult for the system to become stable, and here is the problem where the system or this MRP is going to help us. Now how MRP works? So very quickly we will try to understand certain terms which are related to the processing of the MRP. So basically three important stages are there in any MRP system: input stage, processing stage, and finally the output stage. So till now we have been discussing the input stage only, in which we have seen what is MPS, what is bill of materials, what is inventory status file, and now we will just quickly go through the MRP working, how it works. Now first term to understand is bucketing. At what time and in what quantity a product is needed. MRP starts with consolidating period requirements for different end products. These time periods are called buckets. It adds services or spare parts which are not included in MPS. Now MPS tells us that this much number of product has to be produced by such and such week. If you remember in the same lecture, today's lecture, we have seen one diagram in which we have seen that in this week, this is the requirement which was a MPS schedule or master production schedule slide. Here we see that if certain spare parts are not shown in the MPS, that will be added here. Part explosion, each item exploded divided into constituent materials. Now from MPS we know 100 has to be produced. Now this 100 will be exploded into its subcomponents. Offsetting, displacing requirements by a period equal to the lead time of the product. Now we know what is a lead time. Now the requirement will be seen and understood that when a particular order should be placed, so that whenever the requirement for that particular component is there to be assembled in the final product, we should be ready with that particular material. So that basically is offsetting. If you remember the diagram, there on x-axis we have shown what is the offset. Then the aggregation, finding gross requirements for each component or raw material. Now we will add up the requirements for each material, or we will see the final product what is going to be the aggregate requirements of the subcomponents. Then netting involves modification of aggregate or gross requirements. So what will be the net requirement? It would be the gross requirement minus the inventory on hand minus safety stock minus inventory allocated to other users. So basically we will be able to judge what is the net requirement. That will be from gross requirement, whatever we are having, that will be subtracted what is the safety stock, because we don't want to use the safety stock. That is only for certain exigencies or certain, because of certain lumpy demand. If requirement arises, then only we are going to use the safety stock. And similarly inventory allocated to other users. Now we see that so many different products are manufactured. So for any other product, if we have already allocated certain inventory items, with that will be subtracted in order to get the net requirement. So gross requirement minus these three components, this will involve the netting. Procurement schedule, the requirement is now advanced by a lead time for final assembly, pertains to the production process lead time. So the requirement is now advanced by a lead time. Lead time here pertains to the production process lead time. Now we know that this much would be required. We have identified this much would be required. Now the lead time will be used for the procurement of that particular item. Now lot sizing, this is used to consolidate the requirements in pre-specified lot sizes so that economic order quantity may be ordered. If you remember the lectures on inventory management, we have very clearly understood what is economic order quantity. Now economic order quantity basically minimizes the total cost. So we always want to order the economic order quantity. So that order always we want to place in order to minimize the total cost. So the lot sizing will also be done here. So this is used to consolidate the requirements in pre-specified lot sizes. Now we have already found out that is pre-specified lot size, that is we have already identified what is the economic order size. So that order size will be used here in order to minimize the total cost. Now MRP system will generate the output. Till now we have seen what is the input, three different inputs, how this input is influenced by other factors, that also we have seen. We have seen how MRP works. Basically, it is able to generate that when order has to be placed, in how much quantity it has to be placed, and it is a self-adjusting type of a system. Now, what type of outputs it will generate, that we need to understand. Now, primary outputs in this case will be planned order schedule, that we have already seen when we have understood that how it works. Changes to planned orders, certain times there are so many changes that keep on happening in the enterprise, so changes to planned order will also be a primary output of materials requirement planning system. There will be certain secondary outputs, and now in order to understand this MRP output, these can be generated after 1 week or 15 days depending upon how the requirement of the information is desired by the company. Secondary outputs: planning reports, performance reports, exception reports. So we will just have a brief introduction to all these outputs. Now, MRP outputs, primary outputs, if we see, we have seen two types of outputs, primary outputs and secondary outputs. So the primary outputs are planned order schedule. Now, this is used to determine future production and supply at suppliers, and along with guide for in-house production schedule. Now, we will get a complete planned order scheduled at the supplier and as well as at our production schedule, also at our in-house production schedule. So this is used to determine future production and supply at suppliers and along with guide for in-house production schedule. Changes in planned order, this is also a primary output. Modifications in previously planned order, so if there are certain changes in the planned order that we have already planned, so those changes will also be shown as an output by the MRP system. What are secondary outputs? First is the exception report, used to point out serious discrepancies such as late or overdue orders. Now, sometimes we are not manufacturing or we are not producing according to the desired plans. So, whenever there is certain discrepancy, that will be given as an exception report. Sometimes we are late, sometimes some overdue items are there, still pending orders are there, those will be given in the exception report. Similarly, the performance report matching the planned order as well as the actual performance, used to determine the agreement between the actual and the programmed usage and cost. So here if there certain discrepancy is there, that will also be given as an output. Similarly, planning report used for future planning of inventory. Now this time we have used certain components. Suppose we want to plan for the complete new year, that kind of output is also given by the MRP system. So basically this outputs will be used by the organization in order to plan their materials in such a way so that they derive certain benefits of installing the MRP software. Now coming on to the benefits of MRP. What are the benefits of MRP? We have seen that there are three stages. First is the input stage, second is the processing stage, and third is the output stage. So many types of outputs we can derive from a very simple materials requirement software. So if we have a MRP software, we can get certain outputs, and how these outputs are to the benefit of the organization, that we are going to see in the subsequent slides. Understanding the effect of changes in the future period. So that is very obvious. I have already told the future planning can be done with the help of a MRP software. So what are the changes that are going to happen, that we will very easily be able to adapt in the MRP system. So adaptability increases. Triggers a process to improve bill of materials to guarantee reliable inventory records and better management. Now if suppose there is a change in the design of the particular product, suppose product A changes, so the design when changes, it will trigger a process because the bill of materials file will be needed to be updated. So that triggering process will be done, and very immediately we will be able to adjust to the new engineering design change, or whatever change has taken place, new engineering design has been incorporated, we would be very easily able to adjust to that type of a design, and it will result in better management. improved customer service, so we can very easily satisfy the customer with the quality as well as with the time, which is very important in today's scenario. Then reduction in lead time. We have seen two types of lead times are there. First lead time is the ordering lead time and second one is the manufacturing lead time. So it will result in reduction in the lead time, because whenever the requirement for a particular material is there, already we know with by the output of the MRP system that material or the sub component or the sub assembly would be ready to be assembled. There will be no delay because of the lack of availability of the material. So when the lack of availability is not there, the material is very easily available, readily available according to the planned schedule, then there will be no hiccups, there will be no delays, and there will be the smooth manufacturing process, and the manufacturing lead time will reduce. It will further lead to the increase in the productivity. So when there is no delays, no breakdowns, no shut-ups, then the productivity is bound to increase. Then the purchasing cost will also be reduced. When you have a better materials management package available with you, the purchasing cost will be reduced. Improve production and supply schedules. That is but natural that production would be improved. Schedule, it will be working or it will be manufacturing at a particular schedule and there will be no breakdown. Similarly, the supply schedules to the vendors or to the people who are buying our product would be very certain. Manufacturing cost will be reduced. Less scrap and rework. So these 2 points are interrelated only. When there will be less scrap and rework, manufacturing cost will automatically come down. Higher production quality. So it will also indirectly result in a higher production quality. So the quality will be more, time required will be less, wastage will be less. So we can see there are so many direct and indirect benefits of using a MRP system. Similarly, capacity constraints better understood. So we will try to take a lecture on capacity planning or capacity management also in order to understand what is capacity management or planning. So here the capacity constraints would be better understood. We would be able to understand what is the capacity constraints. And on the basis of that constraints only the MRP system will work and will generate the type of output which is required. Now there would be certain drawbacks of MRP as well. We have seen that what are the advantages. All those advantages we have been able to very easily outline in the previous slides. So if there are certain advantages, there are bound to be certain drawbacks of the MRP system. What are those drawbacks? Now first is the incorrectness in the supplier's lead time. MRP depends heavily on the correctness of lead time data. Now this basically is a package or this basically is a system. We have used a logic, we have used an input that if we order for a particular component A, we will be able to get that component after 10 days. But if there is incorrectness in this data, we are not able to receive that component A by the end of 10 days. Suppose it takes 12 days, then the whole system may crash, because the system is working on this information that the lead time is known with certainty and it is 10 days. Suppose it exceeds, then the system will not be able to adapt to that kind of a change very quickly. So incorrectness in the supplier's lead time data may result in the failure of the system. Similarly, incorrectness in the inventory data, that is miscounting, unaccounted scrap, items lost in transit. So basically the incorrectness in the inventory data will also lead to the system failure. That is, if we are not having the right account or right numbers of the inventory available with us, then it may result in the failure. Last is the inaccuracy in the manufacturing lead time. That is the change in the customer's demand, change in the workload of the factory. So if the manufacturing lead time is also changing, again we will not be able to adjust very quickly. For example, I say that we have an order of one particular product which the customers have placed an order. The system has generated what will be the requirement of the sub-components that will be used to finally produce this product. In the meanwhile, the demand of the customer changes. He specifies that he wants certain modifications in this product, and according to those modifications the design of the product changes. Now once the design of the product changes, if we are not able to incorporate those engineering design changes in the final product, then the information is distorted for the MRP system to operate. And if those things are incorporated correctly, then we know that this is the final design for which our MRP system is working. And if that information is not incorporated properly in the system, or the input is incorrect, then the system will not be able to adapt and will give some faulty results. So basically, if we have incorrectness in the supplier's lead time data, or there the inventory data is not proper, or the manufacturing lead time is not proper, certain changes in the demand of the customer which are not incorporated into the input of the system, then there are going to be certain failures of the MRP system. So it depends on the information, and the information should be very correct. Any level we are putting the information which is not correct is going to result in the failure of the system. Then there are another inaccuracies. What are those inaccuracies? Those inaccuracies can be in bill of materials structure, change in the design. Already I have told this thing that if there is a change in the design, then that has to be put as an input to the BOM file. If the bill of materials file is not updated according to the engineering design changes, then this is not going to be useful for the company. So inaccuracy in any type of input that we are supplying to the system is going to result into the failure of the MRP system. So till now we have tried to understand that how the MRP system is important for the well-being of the company. So we have seen that how the MRP system works. It works on the basis of certain inputs. The inputs basically are the master production schedule, the bill of materials file, the inventory data or the inventory status file. Then the MRP works. We have seen so many basic concepts of MRP processing, that is bucketing, offsetting, netting, so many things we have covered. And then finally we have seen that if we are using this type of a system, what are the advantages that we can derive out of using a MRP system. And finally we have seen that this type of system is based on the information that we provide to the system. If the information is not correct, it can be the lead time incorrectness, it can be the manufacturing lead time incorrectness, it can be the incorrectness because of the certain engineering design changes, it can be the incorrectness because of the change in the customer demand, that is going to result in the failure of the system. Now finally we would like to come to the conclusion what basically MRP is. MRP is a computerized inventory control system. So I have been using the term package or system again and again. So basically it is a computerized materials management or inventory control system. Now this can also be used as a production planning system that schedules the component items as needed. This we have already covered in this lecture, which will track inventory and help a company in many other aspects of business. So finally we can say that MRP is useful to the companies. Similarly, advancements like MRP2 and ERP have been able to link manufacturing with other areas of business such as finance and marketing. So we have seen that there are so many other packages available, which we will discuss if possible in next lectures. Thank you.
you.